Okay. So we did this slide yesterday. I already printed it out for you. You already filled it in, but let's just start by reviewing it and then we'll go from there. So you've got two type events, mutually exclusive events and not mutually exclusive events. The next set of events that we have to talk about are independent and dependent. So the tricky part in this unit, so in the last unit, the tricky part of the unit was figuring out if it was a permutation or a combination. The tricky part in this unit is figuring out if it's mutually exclusive or not mutually exclusive. Here's one key word that you're looking for. In all of the questions, you will see the word or. If the question has the word or in it, you are using our mutually exclusive, not mutually exclusive formulas. Okay? So on your formula sheet, you get these two words. You get these two formulas. Okay? You use those two formulas if you have the question says the word or. So what's the probability of picking a red tile or a green tile? What's the probability of picking a king or a heart? Okay? So essentially the only difference between the two formulas is they each have, so or, okay? They each have A, B, B. Now we learned in our last unit, or means add and means times, correct? So or means add, so that has held. So or means add, or means add. The only difference is in the ones that are not mutually exclusive, you have to subtract the overlap. And the overlap is the and part of the question. Okay? So the question will ask you for what's the probability of this or this. If they have overlap, you have to subtract it off. If they don't have overlap, then you don't subtract it off. If the question on the diploma gives you a scenario and asks you, are these mutually exclusive, yes or no? You're simply asking yourself, do they have overlap? So if they are mutually exclusive, this is the idea. There's no overlap between them. If they're not mutually exclusive, they do have some overlapping outcomes. Okay? So that's all you're thinking about is overlap or no overlap. Okay? Anything in common. But all of the questions will say or means add, just like we learned in perms and comms. Okay? Here's the dead giveaway. When we get to independent and dependent, if these questions all say or, what do you think all the questions in the next concept say? And what do you think you're going to do with the probabilities? You're going to times them. And that's it. Okay, so page 139 in your workbook, please. Okay, so for mutually exclusive, you're thinking this. For not mutually exclusive, you're thinking that. Okay, so overlap versus no overlap. Okay. So it says in each case, state whether the events A and B are mutually exclusive or not. So the experiment is you're going to roll a dice. Okay, so the outcomes would be 1 to 6. Okay. Event A, an even number occurs. Event B, an odd number occurs. So is there any overlap between those two events? No, there's no overlap. So an even number would be rolling a 2, 4, or a 6. An odd number would be rolling a 1, 3, or 5. So there is no overlap. So these are mutually exclusive because there's no overlap. A card is drawn from a deck. Event A, you get a face card. Event B, you get a club. Is there overlap? Are there face cards that are also clubs? Yes, Jack of clubs, Queen of clubs, King of clubs. Okay, so this has overlap. So these are not mutually exclusive. Okay, so your face cards are jacks, queens, and kings. Your clubs go from ace all the way up to king. Notice a king club and a king face card, they overlap. A queen club and a queen and a club overlap. Okay. This time you're going to roll 2 dice. The dice both show the same value. So that would mean a 1 and a 1, a 2 and a 2, 3 and a 3, all the way up to a 6 and a 6. The sum of the 2 dice is 11. What would you have to roll on the 2 dice to get out a sum of 11? A 6 and a 5. Is there any overlap between those two outcomes? No, right? Because these are all the same numbers. These are different numbers. So there's no overlap. So this is mutually exclusive. Now, that is a diploma exam question. They're going to give you a scenario, and it will be, is these two events mutually exclusive or not mutually exclusive? Are these two events independent or dependent? And you're just going to pick the column in the table that matches. So you would say they are not mutually exclusive and they are dependent, or however, we haven't got to independent dependent yet. But it's a guaranteed question on the diploma. Okay, so no math to do there, just sheer memorization, understanding what it means. Okay, so I handed this page out to you. So again, for mutually exclusive, the questions will all say or. And so the overlap equals 0. Okay, so that's why we're not subtracting off the overlap, because there is no overlap to subtract off. So we've got aces and kings are mutually exclusive, right? So your ace, you've got ace of hearts, ace of diamonds, ace of spades, and ace of clubs. You've got a king of hearts, king of diamonds, king of spades, king of clubs. Mutually exclusive. Okay. If the question was, what's the probability of selecting a king? Remember, there's 52 cards in the deck. So that's the total number. Remember, for probability, it's the number of favorable. So in other words, what you want to have happen over the total number. So how many kings are there in a deck? 4. Out of a total of how many cards? 52. The probability of picking an ace, how many aces do you have in a deck? 4 out of a total 52. So you've got a 1 in 13 chance of selecting an ace, a 1 in 13 chance of selecting a king. It should, yes, it should. So like on past diplomas, they have given this type of situation where they've given you what a deck of cards looks like, and then you could just add it up to see. Yeah. They do expect you to know something. So for example, they expect you to know that there's 60 seconds in a minute, 60 minutes in an hour, 24 hours a day, 12 months a year, 7 days a week. They expect you to know that. But in terms of card decks and stuff, no. And these questions can look a little intimidating because once they explain what a deck of cards is, the question can look really big on your page. But if you already know what a deck of cards is, you can skip all that and just get straight to the question. Okay, so the probability of getting a king and an ace, because remember that symbol means and means overlap. So is there any overlap? No. King or ace, or means add. So we're going to take the probability of A plus the probability of B. So what's the probability of getting a king or an ace when you pull a card out of a deck randomly? 2 out of 13. Okay. The odds are still not in your favor, but okay. Okay, so what about not mutually exclusive? So again, A or B. So or means add, but this time we have to subtract off the and. Or in other words, we have to subtract off the overlap. Okay. So probability of hearts. So there's 13 hearts in a deck out of a total of 52. The probability of getting a king. There's 4 kings in the deck out of 52. So notice on my Venn diagram here, a king of hearts. So it's a heart and it's a king. So it belongs to both circles. So there's the overlap. So how many cards are hearts and king? One of them, king of hearts. So the probability of hearts or king is 13 out of 52 plus 4 out of 52 minus the overlap. So you get out 16 out of 52. Okay. Now, the other way that you could do this question, and I don't know if this is any easier or not, I'm going to show you, but it's not necessary to do it this way. If you recognize that you have overlap, right? You have a heart that's a king. So I'm going to use check marks I'm going to use little ticks to represent the number of elements in each one. So I have 1 king of hearts. And then I've got 3 more kings here. And in my hearts, so there's 13 hearts and there's 4 kings. So this whole circle has to add to give 4. This whole circle has to add to give 13. So that means there's going to be 12 more things in there. If you did it that way, you could forget the formula entirely and just go 12 plus 1 plus 3, which is 16. My universal set is every single card. So 16 out of 52. And you'll get out the exact same answer. The reason why that's working is in order to get this 3, I subtracted off that 1. In order to get this 12, I subtracted off the 1. So I did the subtracting by 1 as part of filling in my Venn. So some kids go, you know what? I did really good in set theory. I'm going to stick with that because that worked for me last unit or 2 units ago. Some kids go, you know what? Actually, this formula is super handy. They give it to me, or means add everything up, subtract off the overlap. It's how your brain processes this information. It's entirely up to you how you choose to go about doing these questions. Is there a time where the Venn diagram won't work? No, not in 30-2. Okay, so I want to show you those 2 ways, not to confuse the heck out of you, but to show you that there is a choice. Okay. Okay, let's get out of this screen here. So you actually have this question on page 139. Okay. What you don't have on page 139 is this diagram of all the different decks of cards. Okay. So we've got, consider the experiment of drawing a card from a standard deck. The following events are defined. So event A is selecting a face card. Event B is a red card. Event C is a club. D is an ace, and E is a black. Okay. So which parts of events are mutually exclusive? Okay. So what I do is I usually just list out the elements of the set, just like we did in set theory. So a face card would be Jack, Queen, King, any suit. So essentially, it's any of these, right? That's A. A red card is selected. So a red card is selected would be any of those. Do they have overlap? Yes. So those 2 are not mutually exclusive. Okay. Event C, a club is selected. So a club is this one. So this is event C. Does event C overlap event A? Yes. Does event C overlap event B? No. So that means B and C are mutually exclusive. B and C is one set. D, an ace is selected. So D is just selecting an ace. Okay. So does ace overlap face cards? No. So ace and face, so that's A and D. Does ace overlap hearts or overlap red? Yes. Does ace overlap clubs? Yes. Okay, one more. A black card is selected. I'm out of colors. Let me get a new color going here. Let's go with, yeah, let's use highlighter. So what was the last event? Black card. So black card is anything here. Okay, so did black overlap face? Yes. Does black overlap red? No. So that is event B and event E. Does this one overlap the green? Yes. Does this one overlap the blue? Yes. So those are my mutually exclusive. Now, if you know another way of doing that, go for it. I'm a visual person. Even if it's messy and cumbersome, I almost always need the picture to make it make sense in my brain. Okay. Of these pairs, so of these ones, which are complementary? What does complementary mean? Opposites, right? It means the not. Okay. So if I put two complementary events together, right? So when you put two complementary events together, you have to get out all your outcomes, right? So picking Morgan and not picking Morgan, if I put those two events together, I cover everybody in the class, right? So which of these two events cover everything all together? B and C, A and D, or B and E? When I put the two events together, you cover every single outcome. A red card and a black card, right? Think about it. If this is saying pick a card that's red, this one is saying pick a card that's not red. If it's not red, what is it? Black. If I say pick a card that's black, the complement would be pick one that's not black. Well, what's not black? Red. If I say pick red or black, you're like, awesome, 100% chance of happening here, right? Because when you add them up, you get everything covered. So B and D are also complementary. Okay, now, I don't think you're going to get card questions on the diploma. Unfortunately, your workbook likes to do lots of card questions, but it shouldn't matter. If you understand the process, it doesn't really matter what the scenario is that we're playing with. The only reason why they're hesitant on card questions is just because they have to explain a deck of cards to everybody. And even that being said, even if you get the explanation for a card deck, you still don't have the same understanding as somebody who's played poker their whole life, or, well, not their whole life, but you know what I mean, right? And every question on the diploma has to be a fair game. Like everybody has to understand the same rules. So events have been represented on a Venn diagram. So you've got events A, B, C, and D. State all the pairs of events that are mutually exclusive. So again, what you need to get into your brain is this means no overlap. That's what you need to get thoroughly implanted in your brain. Okay? So which events have no overlap? What's one pair? A and B. What's another pair? A and C. What's another pair? A and D. What's another pair? One more. B and D. Those are all the ones that have no overlap. And again, that could be a diploma exam question. So they might have the sets numbered 1, 2, 3, 4. and they might give you a list of 6 or 7, and they'd say how many of these statements, how many of these pairs are mutually exclusive. So they might have those 4 as well as B and C and D, and that would be it. So it'd be 4 of the 6 would be mutually exclusive. But again, you got to know what the word means in order to be able to do the question. Okay. Okay, so I just put the formulas back at the top, but I'll show you how to do this with formulas, and I'll show you how to do it without. Okay. So use the given information on the probability formula to determine whether events A and B are mutually exclusive. Okay. So if they are mutually exclusive, that means no overlap. Right? So probability of A or B. So 1/4 plus 1/3. Okay, and again, this means or, right? That little U, union. So I've got 7/12 equals 1/4 plus 1/3. Is that true? So punch into your calculator, 1/4 plus 1/3. Do you get 7/12? Yes. Okay, so this is true. Okay, so then they are, yes, they are mutually exclusive. Now, let's say we got out 11/12. So we have 11/12 here, we have 11/12 here, and 7/12 there. That means there must have been a chunk that we'd have to have subtracted off in order to get 7/12 to equal 7/12, which in that case means that they're not mutually exclusive. Okay. Now, they can't ask yes, no questions on the diploma. They can make it into somewhat of a true false. So for example, on a numeric response question, they could give you a bunch of statements. And if the statement is true, you would write a 1. And if the statement is false, you'd write a 0. They'd tell you the code to use. So they would say events A and B are mutually exclusive. And they would give you that information. And you would put a 1 because it's true. If it was false, you put 0. So they can do that. But that's about the extent of it. Okay, back to cards. Okay. Do you have this question? It should be on the next page. Okay. A card is drawn from a standard deck of 52. What's the probability that a 9 of diamonds or a heart is drawn? So again, or means add. Okay. So probability of 9 of diamonds. So how many 9 of diamonds do you have in your deck? 1 out of 52. How many hearts do you have in your deck? 13. Okay, so now you have to ask yourself, is there overlap? So 9 of diamonds is right here. A heart is right here. So is there any overlap? Nope. So then you don't have to worry about subtracting anything off because there's no overlap. So 1 over 52 plus 13 over 52 is 14 over 52, and then you would just reduce that down. So 7 over 26. And again, you can leave the answer like that. You could write it as a decimal, or you could write it as a percent, right? All the answers are considered equal. So 14 over 52. So that's 26.9 or 0.269. Okay. So in other words, you reach into that deck, you got about a 27% chance of getting a 9 of diamonds or a heart. That's what that means. Okay. Okay, a 9 or a heart is drawn. So or again means add. Okay, so what's the probability of getting a 9? How many 9s are there in the deck? There's 4. How many hearts are there in the deck? 13. And again, we're going to check for overlap. So we've got the hearts here. A 9 is anything in this column here. Do you have overlap? Yes. How many cards overlap? 1. So we would minus off the 1 out of 52 that overlaps. So that would be 16 out of 52, and then whatever that reduces down to. Four over 13. Okay. Now, for these not mutually exclusive ones, you can also do them by a Venn diagram. So you have to recognize that they are going to overlap if you're going to do the Venn. Okay. So the probability, so the 9 and the heart. So you have to recognize that you have one card in here that is a 9 that's also a heart. You've got 4 9s in your deck, so that means this whole circle has to go 3 plus 1 is 4. You've got 13 hearts in your deck, so that means that's going to be a 12, because 12 plus 1. And now you just add them up. 3 plus 1 plus 12 is 16 out of the universal, which is 52. But the key is that you have to recognize that there's overlap first before you do it. I would say in the last semester, it was 50-50. Some kids really like set theory. Some kids really like the formula. It's up to you. Okay. Okay. So I'm going to go quiet. Let's see if you can do this. So I'll stop you after each one. Okay. So blocks of different shapes and colors are placed into a bag. Now we're going to assume you reach into that bag and every outcome is equally likely, right? You're not going to feel around trying to find the this or the that, or the green feels the same as the blue, right? Like they're all equally likely. There's 3 cubes, 1 blue, 1 red, 1 green, 2 pyramids, 1 red, 1 yellow, and 5 cylinders, blue, yellow, and 3 red. Okay? So this is more diploma exam style because everybody should be able to understand that. Okay? Determine the probability that a block selected at random will be a pyramid or a cube. So see if you can figure that out. So just do part A and then stop. Okay? No, I've stopped them for a little few days here. They made me jittery. Like even after, like even if I took like a couple hours to drink it, I found I was like on edge, like snappy. Like, no, I just, no. And I'm like, you know what? That's not the best of me. I don't want to do that. So I'll save them for if I was like I almost got a lacrosse game this weekend and it's a late one. So driving home, you know, it's just in town here. And then he's got another one on Sunday in Didsbury and I'm not doing that. 8:30 to 10:30. So, okay, assuming he plays. I think he got hurt pretty bad in the game on the weekend. So we'll see how he goes this week. Okay, how many pyramids do you have to pick from? How many favorables? 2. Total number. How many things in the bag? 10. Cube. How many cubes are there? 3. Out of how many things in the deck? 10. Now, Is there any overlap? So you always have to check for overlap. Can you select a pyramid and a cube? Is there any way to have a pyramid and a cube? No. Okay. So there's no overlap. So it's just 5 out of 10. So in other words, you got a 1 in 2 shot of selecting a pyramid or a cube. Okay. The event will not be red. Okay. So this one, you don't even need to use the formula. This is just what we did in lesson 1. Okay, because there's no or here involved. It's just one event, right? So will not be red. So you want the number that are not red. So how many shapes are not red? 5. So again, you got a 1 in 2 shot of selecting something that's not red. So this unit, just like in the perms and comms unit, every once in a while they'll huck a lesson 1 question in there. Okay, just, yeah. Don't overthink it. It's what you want over what could happen. Okay, will be red or a cylinder. So again, or means add. So figure out probability of it being red, figure out probability of it being a cylinder, and then check to see if there's any overlap. Okay, so how many are red? 5 red, okay. How many cylinders do you have? 5, okay. Do you have any red and cylinder? How many are red and happen to also be a cylinder? How many? So we're going to minus off 3 out of 10. Okay. So look, and here's the thing. If you don't minus it off, 5 out of 10 plus 5 out of 10 is 10 out of 10, which is 1. That doesn't make sense. 1 means 100% likely, and that's just not right. So it's 7 out of 10. So in other words, you got a 70% chance of selecting either a red or a cylinder. So this one, the odds are in your favor. Okay. Okay, is this making sense? Okay, last example here. Okay, so this is on the next page here, page 141. So it says Tom and Andrew were asked to solve the following problem. So 200 people with neurology symptoms, which include headaches and backaches, participated in the study to evaluate a pain relief medication. All the people who took the medicine and the results were as follows. 60 people experienced headache relief, 126 people experienced backache relief, 36 experienced both. Okay. What is the probability that a person has? Okay. When I see this, my brain immediately goes to Venn diagram, right? Like without even, what am I looking for here? This. That tells you overlap. So for me, whether or not I remembered that formula or not, I would probably jump straight to this. So we've got the headache, we've got the backache. So we've got 36 people in here that got both. So remember, you start on the inside and you work your way out. So the headache circle has to be 60. But I've already got 36 written down. So that means 24 has to go for the headache because 24 plus 36 takes me to 60. For backache, I had to get to 126. So 126 take away 36. I want to say that's 90. Now, add up your three numbers because my universal set has to be 200. Have I missed anybody? So what's 24 plus 36 plus 90? I get 150. So that means 50 people to get to 200 experience nothing, no relief at all. So I don't care about the fact that this is a probability question right now. I'll get there. So if this was a set theory question, the question would say, how many people experience no symptoms? Right? Or the question might say, how many people experience headache or backache relief? So then you would go 24 plus 36 plus 90, right? That was the set theory questions. All we're going to do is change the word to probability. So now you take your answer from set theory and you make that the numerator, and then you put the total on the bottom, which is 200. But your numbers are all right here. So the question says, what's the probability that a person who takes the drug experiences at least one of the two symptoms? Relief, sorry, from at least one of the two symptoms. So that would mean they've experienced relief from this, or that, right? So you would just go 24 plus 36 plus 90 and divide that by 200 because the question is now probability. So number of favorable over total number. So I think that's 150 out of 200. If you reduce that down, I think it's 3/4. So 75% of the people experience relief from at least one. How many experience relief from neither? What number is that? 50 out of 200. Or in other words, 25% of the people experience nothing. Now, could I have done this question using probability formula? Yes. Okay. I think for me personally, I do it this way. I like, once I got my brain around set theory, which I'm not going to lie to you, took me a few weeks in the summer, because I was like, I had to memorize the symbols first. Once I memorized the symbols, I kind of tried to put it into language that made sense in my brain. And then once I did that, I started teaching it. And it was funny because last semester I was so nervous about teaching set theory. Like I put the unit off as long as I could. And as I started teaching it, everybody understood it better than me. And so I would start asking them questions, not because I already knew the answers. Actually, I needed to hear their answers to make it make sense in my brain. Because the way you guys explain it sometimes, for me, it's a, oh, yes, 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 now I see what you're doing. And so actually, once I got through set theory last semester, I was like, you know what? Actually, this is kind of a neat little unit. Okay. So what we're going to do after the bell, we've just got this one example left. I'm just going to show you how to do this using the probability formula, and then we'll go from there. Okay? Okay, so if we wanted to do this question using probability formula, again, if you don't like this method, there's nothing on the diploma that's going to make you do it a certain way. It's just I'm showing you two different ways. So for this first question here, at least one of the symbols or symptoms, what's wrong with me today? Don't answer that. This means probably getting a headache or a backache, right? Because it means one or the other or both, or means add. So you would go probability of a headache plus probability of a backache minus the probability of the overlap, right? Because we know that there's overlap. So 60 people experience headache relief. So 60 out of 200 experience headache relief. Backache relief was 126 out of 200, and both was 36 out of 200. So if you punch into your calculator 60 plus 126 minus the 36 overlap, so that's 150 out of 200, which is exactly what I got right there. So For the neither, what you have to understand is that these two events are complementary. Think about it. If you get headache or backache relief, that is the opposite of getting no relief at all, right? Those are opposites. So all we would have to do for this is go 1 minus this answer. That's it. Personally, for me, I like the picture of the Venn. It just makes more sense. But for some of you who are very, very formula driven, the formula works beautifully. So it's wherever your preference lies. Okay? Okay, almost done here. So 1 to 4, X out number 5, 6, 7, X out number 8, number 9. I have try 5, but that's all the card questions, so that's why I've X'd it out. So let's look at number 10. Okay. Okay. 5 and 8, yeah. Yeah. Okay, so we look at number 10. It says use the following information to answer questions 10 and 11. So the probability that Eric will play golf this weekend is 0.5. The probability that he will play tennis is 0.3. And the probability that he'll do neither is 0.25. What's the probability that he will do at least one of these activities? Okay. Okay, a couple different ways to attack this. If we're talking about, what is it? What sports is he doing? Golf and tennis. So golf or tennis. That's what we have to deal with. So that would be the probability of golf plus the probability of tennis minus the probability of the overlap. And overlap is golf and tennis, right? So the problem is the neither, okay? That to me is what, actually you don't even need to use the formula for this. I'm going to strike this. Okay. Think about Venn, sorry. Golf, tennis, neither. Okay? Neither is 0.25, right? Since we're talking about probability, what does the universal have to add up to? 1, right? 100%, right? So if this is 0.25, right? That's 0.25. What does this have to be? 0.75. And that 0.75 represents golf or tennis, right? Remember, or means add up everything. Does that make sense? So if you read the question, what's the problem that he'll do at least one of these activities? It's saying golf or tennis, at least one of the activities. So the answer is just 0.75. At least one means golf or tennis or both, right? That's what at least one means. So for me, the Venn diagram makes way more sense on this question than the formula. Okay. If we look at number 11, it says the probability that he will play tennis and play golf. Okay, so I'm going to go back to Venn diagrams again. So let's make it, instead of using 1, let's use 100, because then I can use whole numbers. I know, so golf, tennis. I know this is 25% or 25 out of 100. Okay. How big is my golf bubble? My golf bubble is 0.5. or 50, sorry. My tennis bubble is 30. Now, what we are looking for is this thing right here. So if you remember back to set theory, you put an X here, and you remember you worked your way out. So we would go 50 minus X, and this one would be 30 minus X. So now we set up an equation. So we take this plus the overlap plus the other circle plus the neither, and we have to get out 100. So 50 plus 30 plus 25, 80, 105. Now what's going to happen here with the negative x and the plus x? They cancel out, but I've still got a negative x here. Okay, so 105 take away what will give me out 100? What's this have to be? 5. So if you go back to your picture here, 5 is the overlap. Overlap is golf and tennis. So that 5 represents 5% or 5 out of 100 or 0.05, which is the answer to the nearest hundredth. Okay. Now, did I see any questions like that on the diploma? No, I did not. But technically it's fair game. Okay, but it's definitely on the excellence end, right? Because you're combining set theory with probability. You're working your way out using an equation. Okay, I want you guys to try number 12. Do it through Venn diagrams. See if you can figure out the diagram for number 12. See if you can figure out how to set this up. So just think of it as a set theory question at first, and then try to think of it as a probability second. Okay, so it says in a group of 80 elementary students, so 80 is my universal, 48 like cornflakes. So 48 is going to be for this whole circle. 22 liked both cornflakes and oatmeal. So I know 22 goes there. So now I know that. I know then that this is going to be 26 because 26 and 22 is 48. And 20 liked neither. And the question is, the probability to the nearest hundredth that a child selected at random from the group likes only oatmeal. So only oatmeal means we need to find this number right here. So that's going to be our numerator. Because it says probability, we put it over the universal set. So the only difference between this unit and set theory, I just wanted the numerator. Probability, you go numerator divided by total. That's it. So I need to figure out, I don't know the total here. But let's say it was 50. I would go 50 minus 22 to get out that number, right? So whatever this is, I'm going to minus 22 from it. So now I'm going to set up my equation. I'm going to go 26 plus 22 plus 22 minus x plus the neither gives me out, so everything I need. So this, add them all up. So, oh boy, 44, 54, 64, 70, 80, 90. Okay, so what does x have to be? 10. So I know, oh, Okay, I added up wrong. Okay, so 26. Whoa. So 26 plus 22 is 48. 58, 68. 68 minus 22 is 46 equals 80, right? Oh, that's not going to work either. So 26 plus 22 minus 22. Well, the 22s will cancel out. So yeah, you get 46. So that's going to be plus 46. So if I minus 46, it'll be 34. So that means then that this circle here is 34. 34 take away from 22 leaves 12, right? Okay. So then 12 out of 80 is the answer. Now, to build off what you guys said, as soon as you said it, I was like, oh, of course, that's stupid. So if you don't want to do this the algebra way, what you can understand is that if 20 are neither and the total is 80, then what do these two circles have to add to give? 60, right? Because 60 plus 20 has to give 80. So if you go 26 plus 22 plus what gives 60, you'll get to that 12 without having to set up an algebra equation. Yeah, I was over mathing. Okay. But no, that's fine. So it's just, to me, like set theory, if I don't know something, I put X in and I subtract my way out, right? Just because that's how we did it in set theory. But in probability, actually, it's a little bit easier because you know that this has to add, these two parts have to add to give that total, and then you can just start subtracting off. So, okay. So that's it.